Two-step equations, just like the name suggests, are equations that you can solve in just 2 steps. Let's take, for example, the problem 24 equals 2 times the quantity k plus 4. There's nothing that needs to be done on the left side of the equation, so let's focus on the right side. I see that we have distributive property. 2 times k is 2k, and 2 times a positive 4 is a positive 8. We'll bring down the equal sign and the 24. Let's get all of the constant terms to one side of the equation. So I would like to subtract 8 from both sides. We have 24 minus 8, which is 16. Bring down the equal sign. Nothing's happened with the 2k, so we'll bring that down. And 8 minus 8 is 0, so we don't need to write plus 0. We learned in the last lesson that that would be the identity property of addition, and adding 0 does not change the value. So now we just need to break the 2 off of that k. So let's divide both sides by that coefficient. 16 divided by 2 is 8. 2 divided by 2 is 1, and 1 times k is k. So we see that our k value is 8. We could leave our answer in this form, 8 equals k, or if you felt better about it, you could rewrite as k equals 8. Either answer is correct. Let's take a look at a problem that has a fraction in it. I know sometimes fractions make things look a lot more difficult than they actually are. So let's take a look at an example of a fraction problem. Let's say that we have the statement b over a negative 2 minus 6 equals a negative 16. Since I can do an addition or subtraction process without disturbing the fraction, I'm going to start there. So I'm going to start by moving this negative 6 to the other side by adding 6 to both sides of the equation. So the b over a negative 2 has not changed. Negative 6 plus 6 is 0, so we'll bring down the equal sign. Negative 16 plus 6 is a negative 10. Now that the only thing on one side of my equal sign is a fraction, I will address that denominator right now. If I multiply both sides by the denominator, I will essentially eliminate my fraction. So I'm going to multiply both sides by a negative 2. I do this because negative 2 divided by itself is 1, and 1 times b is b. Negative 10 times a negative 2, negative times a negative is a positive, 10 times 2 is 20, so our b value is 20. Now if we were to look at one more fraction example, so that you could just make sure you know when you can deal with the fraction and when you cannot, let's look at the statement negative 1 equals x plus 1 over 10. Now notice on this particular example, on the right side of the fraction, the right side of the equal sign, everything is a fraction. So since that side of the equal sign is completely a fraction, I can eliminate that fraction by multiplying by the denominator. So I'm going to multiply both sides by 10. 10 times a negative 1 is negative 10. And over here, 10 divided by 10 is 1, leaving me that entire numerator. So now all I need to do is subtraction property of equality. I'll subtract 1 from both sides of the equal sign, leaving me a negative 11 equals x. Or remember, if you're more comfortable with having the variable on the left, you could write it as x equals a negative 11.